All right, what is up, Dr. Mills and the TA? Please, please ignore the time. It happens. So here we are. We'll start from the ground up. So this program was designed with a lot of requirements, and it was basically to introduce operator overloading, which did finally click. Took a while. First thing, 3 private data member functions with getters and setters for each. So, pretty simple. Got the private data, which is the day, month, and the year. Pretty straightforward. Got some private functions in there. We'll skip that for now. We'll go to our constructors. We got our default constructor. Basically, this was made if they enter a date that's not valid, it will tell them, but it will just resort to the default constructor. This is second constructor. This is our converter constructor. This allows us to pick the year for our default constructor. It's like a default constructor, but we're picking the year this time. And then finally, we have a parameterized constructor, which we use for date 3 and date 4. So we'll just slide that in there. And basically, we have the getters and setters for both. We need 3 for each. 3 getters, 3 setters. We need to get the day, month, year. We need to set the day, month, year whenever we please. The next requirement was the date class should have the following constructors, which is what we just went over. And the next thing, which was not what I personally did next, I took Dr. Mills' instructions and I did go steps 1, 2, 6, and then I kind of just went 5, 4, 3, or 5, 3, 4, kind of just mixed in. But yeah, so step 6, we'll go to that next since it's most relevant. Step 6 was the operator overload for type O stream, which is basically cout. So just like in class, we did the O stream reference, put it as O. That's a constant date reference because we're making a copy of it of date, whichever date class we put in it, whether it was date 1 million or date 1. So we can see that's applied over here. Basically, you could have done this 2 ways. For me, arrays, case. I took micro last semester. I like cases. They're switch statements, sorry. Very simple to make, very easy to implement in my opinion. So, we had to create the string for the name of the month, and basically based on the number 1 through 12, whatever month was put in, that was converted and set to a string according to the correct month. So, it's pretty simple, and then you had to return it. It's a big deal. If you don't return it, it won't work. So you just return it into the format that was required in step 6, which is month, comma, day, or month, day, comma, year. And then, yeah, that was the format for all of the prints when you printed the dates. Next, we did step 5. Date class should not allow invalid dates or dates before January 1st, 1900. This is kind of just scattered in to pretty much everything. So you can easily find that if you just go like this, 1900. So for each single one of the constructors, the default, well, just for the default and just for the converter and the parameterized conversion constructor. My apologies. So basically, we just want to verify that it is not before. So 1899 or earlier won't work, as you see here and here. And if they fail to enter that, it will just set it to the default constructor, which is January 1st, 1900. And you can also see that in my notes, I believe. Yeah, here we go. So would put year 1900. put year greater than 1900, because how you think, you're like, okay, you want year to be greater, but actually it's backwards because the years, 1899 is less, but when you think of it, it's backwards. So yeah, the next step that we did, which was the subtraction operator. So I was an advocate of this step because doing this before any of the comparison operators kind of like streamline this for me. So here we are. So we have and it's a member, it's not a friend. So that was like the only one that wasn't a friend. So the operator subtraction, just named it compare because we're comparing. That can be found right here. So you compare it. Just comparing just because you have one already, and then you compare it with the next one. So we have total days for the first date, total days for the second date, and then days 1 and 2. And basically total days 1, total days 2, don't get it confused, is to see if, basically just see the days in the year as seen by the function name here. Go up, which we can I guess bridge into here, where we have 3 of the very needed functions. So they're all in the class date. 2 of them are ints, 1 of them is bool. So basically we'll start with the bool. That's pretty simple. There's just an algorithm to see if the year is divisible by 4. Well, if it's modulus 4 equals 0, so if it's divided by 4, no remainder, and divided by 100, not with a remainder of 0, or if it's divided by 400 with a remainder of 0, it'll be true, which means it is a leap year, which means that it'll have a different amount of days. So then that moves into how many days are in a month. Well, think of it, I count by my knuckles: January, February, March, April, and the upper ones are 31. So that's what I did. And months 4, 6, 9, 11. So March, June, September, November, all 30 days. Else return 31 because we had the if statement before, which only needs to check February. And then with that, we can move into the days in year, and basically this is pretty straightforward. Like I put in the comments, you can find the exact number of days in said year, and you add user entered day to total. So yeah, that one's that one. Not really much to say about that. So now that I explained those, this is a little more clear. Sorry. So it's a little more clear. Calculate the days in the year. Then you can add it to our total days, which starts at 0. And yep, this calculates. If it's a leap year, it's going to need 1 more day, like we said. And then the second part is the same thing, except with the second date that we are comparing and subtracting. And after that, we can subtract, creating the operator overload, allowing us to subtract. And we included CMath, so these are also included. We included CMath and string. We use string, straightforward. We use CMath just for absolute value because it makes it easier rather than creating a statement like a more complicated function. Just get the absolute value. If day 1 is bigger than day 2, it's still the same thing. So yeah, I'll show you in the terminal. We also have the next step, step 3, moving backwards, which is basically all the comparison operators. I mean, this one was definitely a little difficult, but once you figured out how to do one of them, then you can just use that data to create the next one. So basically, if you have this one, you can just do the opposite. So like you have this one, okay, like if this one's true, this one's not true. If this one's true, this one's not true. So it's once you just do these and you can do, that's it. So Basically just comparing the days, months, years, returning true or false based on that. And then this one, just two things. See if they're all equal, because you have to check for that. Because if you just have less than and they're equal, it'll return false. So, yep. And then these are just the opposite. The equal one is basically a build off of this, but simpler. And the not true is not true. Straightforward. So, yeah. And then, setters and getters, didn't really get into that. But these are pretty straightforward. Basically, the setters are just, if it was just a number, you would just be setting it with the this and the arrow operator, or not operator, sorry, the arrow. And yeah, we just want to make sure that this is a real date that exists and it's not before 1900, which is what was requested in the assignment, or required. Then you got your getters, pretty straightforward, just returning data. So yeah, we can move on now. We got the main. Include sebas.h, sebas.h, which is basically has all of our namespace, string, cmath, IO stream. Getting into our main. Had to initialize a few obvious variables. So you got, first one is just the default constructor. There was some issues I had with this. I was initializing before I initialized dates, all of them right after each other, like date 1, date 2 right here, and I realized after some debugging, I realized that the user needs to pick the year, because if it doesn't, then it'll just automatically assume that it was not a correct year in our scope, and it would just say invalid. It would go here, and it would say this is not a valid date, setting January 1st. So each one has its picks. Date 3, date 4 are the ones that will be used to compare and subtract, which are the parameterized constructors. And then I listed them out for clarity, and then show the results of each of the required operations. And then absolute value again. Now that I think about it, I don't really need it here. It's kind of double dipping, but can never be too safe, I guess. And then that displays that. So it's the make file we used. Pretty straightforward. And before we get into the terminal, I'll go over some other things. So it was stuck on why subtraction wasn't working, had dot operator mixed up. Basically what I meant by this was here, compare dot. I was missing it on one part, and it was still working, but it was just giving me like some mumbo jumbo, wasn't correct. So, after some debugging, I discovered that. Not really a syntax thing, but yeah. And then the subtraction operator was difficult. Going back to this, without leap year and days in year, I did it backwards. I was building the operator minus before I did days in year and leap year function, and I just couldn't figure out how it worked. So I went from the ground up. It was like, okay, we need to calculate how many days are in a year first. We need to calculate if it's a leap year. And yeah, we need to know those things to perform this. So that took quite some time. And that was pretty much it for my difficulties. That took a lot of time. So let's get to testing. Let's get to the fun part. Double check. All right, date 2. Let's pick a year. I can show you first, 1899. Not a valid thing. So we can just, you can see that. So it automatically set it to 1900. We'll do January 1st, 2000. And then let's do my birthday, November 25th Well, it's 2002, but for the sake of this, we'll put 1900. I put 190. Okay. Let's ignore that. Pick a year. So you already saw it doesn't work. 1899. We got that. But I'll put it again just so you can see it in the print statements. Pick a month first. Let's do this one, 1901. And then let's do my birthday this time so we can actually do it, 2002. Boom. So as you see, when you put an invalid date for any of the three, it'll just set it to the default. So here we have January 1st, 1901, which is date 3. Date 4, November 25th, 2002. That's my birthday, Sagittarius. The results from comparing dates 3 and 4, basically January 1st, 1901, comparing if it's less than November 25th, 2002. November 25th, 2002 is more recent, so it is true. So if that one's true, this one is false. Less than or equal to, since it's true right here, since it's false right here, you can build off one another. Not equal. And since this is not true, this is true. Got days between. User entered date 37,218. Now, I don't know if that's right, but this website does. January 1st, 1901. And then I put November 25th, 2002. 37,218. Cha-ching. So let me show you now. So you pick a year. 1900 for the... Let's put 20. 100. And 2001. That's not valid. Computer knows too. Pick a month. 1,100. 1,000. 2,000. That's not valid either. And we can actually see this comes up. You can see that this is working properly as they're set equal. This one's working properly. They're equal. And this one, they're all working properly, but you can see that these stand out. And that is my programming assignment 2. I apologize for the procrastination. This is new. Can't wait for number 3. Thank you.